I don't really talk about this theory too often of whether we're in a black hole. That seems to be a popular speculative theory that we're in a giant supermassive black hole. I would not rule that out. Intuitively, like, it seems to me that there's not enough time for a black hole that large to form to make it, 13 billion years since the Big Bang. It doesn't seem to me like Earth just formed a few billion years ago. It just doesn't seem like the evidence suggests that's enough time for a giant black hole to form. But we were just talking, and you said the curvature of space implies a black hole. Mm-hmm. And I think that's a great point, because there's some evidence that, there's some theories that the universe is flat, and then there's theories that has like a slight curve. If it has a slight curve, to me that's congruent with being in a really, really, really big black hole. Right. Because I think if it was that big, the curvature of the black hole would be so small due to the black hole being so big. Like, say you're just past the event horizon, I bet the curvature there is just slight in a supermassive black hole. Correct. Because, I don't know. I don't know if that's even true geometrically. Maybe someone smarter who's good at geometry can tell me, but I feel like as you go towards the edge of, like, the end of the funnel, I feel like the curvature is probably just more slight than as you get towards the singularity. So something interesting they could study is...
Does it get more pronounced over time?
Yes. Like, is there any micro detection that the curvature of space is actually increasing? Mm-hmm. That would be fascinating. Another fascinating thing, like, I don't think we have tools this sophisticated, but if we did, like, put something on our head and put something on our feet, is there very slight spaghettification? If you could detect a difference of anything between your head and your foot, but I don't think we have the tools for that. But imagine we did have the tools for that. Mm-hmm. That could prove that we're in a black hole if there's a difference there, because...
And we're talking like maybe we haven't...
Because I just want to finish just let me finish the thought, because that would imply spaghettification.
Yeah, but that's only for the singularity, right?
So as you go past the event horizon, I think it's like normal for a while, and then you slowly start to get spaghettified.
Right. So I don't think...
So there's a process. Once you go past the event horizon, gravity's pulling more on your feet than your head right away.
Right.
Because light can't escape.
Right.
So right off the bat, it's happening. It's probably just so minute you can't detect it. So we could be in that phase,
Or we could be not at that phase, and we just haven't. We're at the very outskirts of it. We're at a point where we're not in a place where it's...
That's what I'm saying. We could be just past the event horizon, where we're not being spaghettified.
Yeah, we're not in the singularity, but we're riding the wave of the outskirts.
I think you get spaghettified before the singularity. It's like a process on the way to it.
Yeah.
Yeah.
But imagine if it's super massive and you're traveling around. Mm-hmm. You might be on the outskirts of it, but slowly creeping in over billions, trillions of light years.
Correct.
So you would never really notice.
Yeah. That's why we need detectors, like something to put on our heads and feet, like a spaghettification monitor, to tell if that's what's happening to us. If that's happening to us and our feet have more pull than our head, then, we're probably in a black hole. And that would explain the curvature of space-time a little better than, it would just explain it. It would give at least an alternate theory, like the curvature could be due to the black hole. I feel like that would be a fact at that point.
Yeah.
If you're in a black hole, the curvature is probably the black hole.
Right.
I almost feel like that's definite. And that's interesting. It could suggest there's something outside the black hole, a different type of fabric that's actually flat. Because it didn't get warped by gravity. Could be totally flat outside of, if we're in a black hole outside of it.
Right.
The real universe could be actually flat.
It's very true.
Yeah. So, anyway, that's all I got to say about this theory right now, at least, that we're in a black hole. I think about this sometimes. We talk about it. You like it a lot. I'm not sure.
I don't like it.
I mean, you think we're in one, I mean.
I feel strongly that is the case, but I still hate it.
Yeah. But you think we're in one.
Yeah.
Yeah. I never thought we were in one, but the more I think about this, it would explain a lot of things, you know?
It explains how weird and, like, not standard the rules are.
Yeah.
Because, like, what's happening in a black hole? It's a ton of weirdness.
Yeah, it's an extreme condition. It could explain why we can't unite quantum and gravity. It could explain that. Gravity's weak, though, and in the black hole it gets strong. So we'd have to be really far on the edge, I think.
I think we're far on the edge.
Yeah, we'd have to be, like, just past the event horizon. But yeah, it would explain a lot. Maybe I need to think about this more and think what it would explain and then make a different video. But for now, I just want to say I'm undecided on it. You like the theory. I want to stay open to it. To me, it doesn't seem like there's enough time for something that big to form. But maybe that's just me being, like, you know, too stuck in this universe I'm in and thinking about time, you know? Like, time probably is, like, we know it's, I don't want to get into it, but it might not even be a thing. So if it's not even a thing, I don't want to get too much into being caught up with, like, there's not enough time for it to form. So I'm going to stay open to it and think about it more. That's where I'm at. I like it. I don't love it. I think it's possible. So yeah, that's that.